Hello everyone. Now we are going to discuss this question from the EAS reaction, which is going to be comparison of the rates of nitration for the different benzene rings. So EAS is electrophilic aromatic substitution, where hydrogen atom of the benzene ring is substituted by some of the electrophiles. So we have been given some different 8 different compounds over here, and we are supposed to be finding the rate for the nitration, and we have to choose those ones where rate of nitration is less than the rate of nitration of benzene. So we'll be seeing these one by one. First of all, we have named these compounds 1 to 8, and then we'll be seeing what determines the rate of EAS reactions. So what we understand is the groups which are having minus M effect, like electron withdrawing effects basically, whether these are minus M, minus H, or minus I, that is the isomeric effect, minus hyperconjugation effect, or negative inductive effect. They will be decreasing the electron density on our benzene ring, and as we understand, if there is less electron density onto the benzene ring, ability of this benzene ring to donate the electron, because what happens, this benzene ring is donating its electron to the electrophile in the EAS reactions. So if benzene ring is already electron rich, it will be finding it difficult to donate the electron, and if it is finding it difficult, the rate of reaction is going to be relatively smaller or less. That is what we are trying to say. Less electron rich, less likely to attack onto the electrophile, less the rate of reaction in these cases. So the compounds what we have been given, we can see the minus I or minus M or minus H in different cases. 4th and 5th compounds are interesting case. So what they have done, compound number 4, C double bond O, this is electron withdrawing group attached to the benzene ring. So for this ring, electron density is less, but this phenyl ring, what has been kept over there, this is bonded to oxygen, which is having electron donating nature. This electron density on this benzene ring is higher than the unsubstituted benzene ring. And in the second case, over here they have done the same thing. This ring is, they have written with this ring is basically same as that. So they have written the compound in different fashion, and if we don't realize that phenyl, the other phenyl group is going to be faster, because they asked in which case the rate of reaction will be faster. So if we compare these two, in this first compound, the benzene ring onto the left, this one is going to react with NO2+, and that overall rate of reaction, if you compare with the benzene ring, this is going to be faster. And in the second ring, because this ring is electron rich, this is going to attack onto the NO2+. So whether you take compound number 4 or 5, the phenyl ring attached to oxygen is going to be electron richer than the benzene ring. That is going to attack to the NO2+ as the electrophile, and the rate of reaction for either of these two compounds, because they are actually the same compound written different way, you compare either of the with respect to electron ring which is richer, we need to compare. So the phenyl ring is going to be always electron richer. This is going to react faster in comparison to benzene ring. So this is not going to be our answer. This is going to be faster than the benzene ring. Next compounds which we are going to see is, okay, this discussion we just have had. The other compounds which we are seeing, they are pretty much straightforward, because in the first one, methyl is having plus H effect, so this is going to be faster. This one is going to be faster because of plus H. NO is having electron withdrawing nature, so that's going to be minus M, that's going to be slower. Boron has empty p orbital, pulls electron from the benzene ring, minus M, that's going to be slower. This we just talked about. SO2, electron withdrawing nature of oxygen, pulls electron from sulfur, sulfur pulls from the benzene ring, that's going to be minus M, that's going to be slower. Cyanide, C triple bond N, nitrogen is more electronegative. Nitrogen pulls electron from carbon, carbon pulls from the benzene ring, that's minus M. So 4 examples as of now we have seen which are going to be electron poorer than benzene ring. And then comes this benzyl chloride. This is quite interesting case. That's because there are 2 different kind of compounds, 2 different kind of atoms present. We have got 2 alpha hydrogen atoms which are going to exert plus H effect, that will be increasing electron density, and there is minus H of 1 chlorine, that is reverse hyperconjugation of 1 chlorine. So now it is going to be a tough fight because chlorine is trying to pull electron from the benzene ring and hydrogen is trying to give electron to the benzene ring, and there are 2 hydrogen which are trying to do so. So what should be the result? The overall electron density should be more than benzene or less than benzene. For that we need to look at some of the clues we might have had earlier, like if CCl3 was present, then the relative activation or deactivation of the benzene ring, versus when methyl was present, the relative activation or deactivation of the benzene ring, how it used to be. Therefrom we can have an idea. So if you remember, we have seen if there was a toluene, because of plus H effect, this is going to be activating, but this is not very strongly. This is going to be weakly activating in comparison to the groups which are having plus M effect. So plus H of 3 methyls group is, although increasing electron density, this is not a huge effect. On the other hand, if we compare with this trichloromethyl, that is CCl3, this was supposed to be strongly deactivating. Like its deactivating nature can be compared to somewhat kind of cyanide or maybe up to some extent to nitro. So if this is strongly deactivating, it tells us the idea. This gives an insight how the electron withdrawing nature of the chlorine by reverse hyperconjugation versus electron donating nature of the hydrogen by plus H, that is hyperconjugation, are going to be related. And here we go. What we'll say, minus H effect of the chlorine is much dominating because of its higher electron demand, we can understand, because of its high electronegativity, and then this is going to be overall deactivating. Minus H can be activating over here. That is the overall situation. So these 5 compounds which we have seen, compound number 2, compound number 3, compound number compound number 6, compound number 7, and compound number 8. These 5 compounds given to us are going to be slower in comparison to the nitration of the benzene ring. So our answer to this question goes to be 5. That's all in this question. I hope you understood all the things we discussed. If you did, please consider supporting this channel. Thank you. Bye bye. Great day.